A pulsar pump is a combined trompe, which is where the water is being carried down in the diagram, and an airlift pump, which is the small pipe which blows the water up in the air in the diagram. And water simply goes down through a pipe and into a chamber and carries air with it, and the air pushes water up through the chamber. Airlift of water doesn't need to be straight up. It can be on an incline too, and that's useful for if the pump is used in an area where they simply where you don't have the height, or you could have a long incline to where you're going to use the water, and it's just useful in certain situations. Here we have a pulsar pump with water being sucked in, water being sprayed, and the exit water, and the entire pump in this case is under the stream itself. So we'll just go over it again. Water sucked in, the black pipe spraying out the water, and the exit water below the stream. Next we have a pulsar pump beside the river, and it's pumping much higher. You can just see it in this old video I have, and we'll play in the sound of the pump as well, just to give you an idea what it sounds like. Next up, we're going to show you a little model of the airlift process, and that's the small pipe in the middle of this little diagram where the air and water mixture is being blown up in the air through the little small pipe, and it comes to you now. Airlift pump model, pumping up water up to 6 feet high, and it splashes down nicely on my lovely assistant, who is maintaining the pump. You can see the water just hold up as the water goes up. It doesn't, when pressure is off, it doesn't instantly go back down. It stays held up very good in the pipe. And there's the pump working away. Next up, we have the water carrying air down in a model, and it's the same as what is happening in the large pipe on the left of your screen now, and this is what takes place in the model that's coming up in the next little piece of video. This would be the way the air bubbles go down in a normal pulsar pump. The model is only 3/4 of an inch wide in the downpipe, so sometimes big bubbles which cover the entire downpipe happen. This doesn't occur in a normal full size, say 3, 4, 5, 6 or wider inch diameter downpipe. Here we have a model of the entire pump. Here you can see the bubbles going down into the bottom chamber. Right down here, quite a lot of bubbles, and it's going pretty fast, and then it's going to come up through the little small pipe, and the air bubbles come up through it and blow out some water. The future of the pulsar pump depends on you, because big science has no interest in it. Here's a pump that has worked for 18 years, has no moving parts, and it's just made of wastewater pipes. So anyone can make one. There's no patents or anything like that, and it just needs to be verified by other people that it actually works. And so that just means making a model, making a pump, and there are lots and lots of uses for this type of pump. The PULSER pump can be used for pumping water, for giving cattle drink, different animals drink. It can be used for washing sand. A PULSER pump could be used for washing clothes. If you're interested in doing experiments, you could improve the airlift part possibly with lightweight pistons. I only show one, but I think it's a possibility to greatly improve it by experimental means, with small experiments. You don't need to do any fancy stuff because big science is just not interested. So check it out, look in more detail at it, tell your friends and anyone who is into experimental science, and I believe we can move this device forwards and get it into use by perhaps millions of people across the world who have low head hydro but don't have the means to develop it with anything other than the simplest device. And the PULSER pump is, I guess, the simplest hydropower device in the world.